definition of functions with an emphasis on composite functions. First thing we need to talk about in this section is finding the domain of a function. If you forget what we say, then on page 221 in a blue box, it tells you exactly what the domain of the function is. The domain is just all of the x's that I can put into my function that give me back a y value that's a real number. So, what we have at this point that's excluded from our domains are what? What things give us undefined answers? If we have a 0 in the denominator of a fraction, and if we have, this one doesn't give me undefined, it just gives me something that's not a real number. We have a negative underneath an even root, right? I can't take the square root of -1 and not get a real number. It gives me an imaginary number, right? But I want a domain of a function is the set of numbers that give me back real number answer choices. So a domain, for the most part, is all real numbers. Except anything that causes a function to have a 0 in its denominator, or a negative number under a radical with an even index. Because remember, index is that number that's hanging out on the outside that tells me what root of it I'm taking. Okay? So, if there's not a fraction and it's not a square root or a fourth root or a sixth root, then my domain is going to just be all real numbers. Right here what I just said.
All real numbers, domain.
So if you will look there at the checkpoint, checkpoint 1, my first function, it says f of x is equal to x squared plus 3x minus 17. Is there a fraction involved here at all? Is there a root involved here at all? So what's my domain? All real numbers. And if you're going to do it in interval notation, instead of writing it out in words or in set notation, you just go from a negative infinity to a positive infinity. Part B, g of x is equal to 5x over x squared minus 49. Now, can I have all real numbers? No, this is not all real numbers, right? There are some things that I cannot have. The things that make the denominator equal to 0. I didn't say 0, I said the denominator equal to 0. So to do these problems, every single time you're going to take the denominator and set it equal to 0 to find out what numbers make that happen. So x squared minus 49 equals 0 says that x squared is equal to 49. So x is equal to a positive and negative 7. Right? You remember that when you take the square root of both sides, you got to have a positive and negative value. So my domain on this problem is from a negative infinity up to a negative 7, and I cannot include negative 7, so you put an open parentheses there. And that's unioned with, so it's included with, from negative 7 to positive 7, another open parentheses that shows that I can't contain that 7, and that's unioned with 7 to a positive infinity. So that's interval notation that shows that I can use every number in the world except -7 and +7. Because it says I can use everything from a negative infinity up to -7. Then I have to skip over -7, and I can use everything between -7 and +7. Then I have to skip over 7, and I can use everything between 7 and a positive infinity. Okay? The set builder notation way to write that is you can have all x's such that x is not equal to -7 or +7. Okay? All x's such that. Okay, it says I can have any x that follows that's got the following condition. X cannot be equal to positive or -7. A lot of times when we write this, we don't write the braces around it. We don't really put true set builder notation. We'll write that for the domain. I understand what you mean here. That's fine. Okay? But in upper level mathematics classes, this is the way it's truly written. When I even left part of it out because I was also supposed to say that x was an element of the reals, but you can get real picky. Yeah. Okay. And then part C, there says I want the domain of h of x when h of x is equal to the square root of 9x minus 27. Okay. So what can I not have under a square root symbol? A negative number. So the way I represent that is I say that 9x minus 27 has to be greater than or equal to 0, because it can't be less than 0. So on these, you can directly find your domain, because when you solve this for x, it will give you your domain. Everybody understand that? Because these are the things that will work. On part B, we found the things that wouldn't work, and your domain's everything except that. When you set this one up, you're finding everything that will work directly. Okay? So I'm going to just add 27 to both sides. So I get 9x is greater than or equal to 27. And then dividing by 9 gives me that x is greater than or equal to 3. So it's all the x's that have the condition that x is greater than or equal to 3. In interval notation, that says I start with 3, and I go up to a positive infinity, and I do include 3. And remember, you put the little square bracket to show that you included 3. Any questions about how to find the domain? All right. The next objective talks about the algebra of functions. So just like numbers, I can add functions, I can subtract functions from each other, I can multiply functions together, and I can divide functions. And the box on the bottom of page 222 gives you all those rules. It says that f plus g of x. So in other words, it's saying add f and g together is the same thing as taking f of x plus g of x. We just take the two functions and add them together and combine like terms if there are any. Same thing with subtraction. F minus g of x means that I'm going to take f of x minus g of x. You just take the first function minus the second function that's in the notation. If you see this notation, it just means take the functions and subtract them from each other in that order. F times g of x does not have a dot between it. Everybody hear what I just said? If they want you to multiply the functions together, there will be no dot between the two functions. That means f of x times g of x. Because we're going to do something in a minute that people get confused all the time. There is multiplication, but there will be no dot between it. No symbol between f and g if it means multiply them together. And then there's f divided by g of x, which just means f of x divided by g of x. Now, there's a problem with this one, right? Because the minute I did the division, it turned into what? A fraction, and the fraction cannot have what? A 0 in the denominator. So this is only true so long as g of x is not equal to 0. And so you're always going to have a domain restriction on the division problems. Everybody hear what I just said? They're going to always ask you about the domain on a division problem because you put a restriction on it. It can't possibly be all real numbers if it's a function that's more than just a constant function. It's got even one letter in it. You just kept it from having all real numbers as its domain. Okay? So let's look at a few of those and see what that looks like. Checkpoint 2. Tells me that f of x is x minus 5. And g of x is x squared minus 1. And so part A wants me to find f plus g of x. Remember, that means f of x plus g of x. So f of x is x minus 5 plus g of x, which is x squared minus 1, right? And then we combine like terms. That's all you do on these. So it becomes x squared plus x minus 6. There's not an x squared to add to it, so I just list the x squared. There's not another x, I just have to list the x, but the minus 5 and the minus 1 are like terms, so I can combine them. Okay, so when you add and subtract, all you're doing is you're combining like terms. Part B wants me to subtract them. So I'm going to take f of x minus g of x. Now, what do we have to be careful of when we subtract off that whole thing? Got to change the sign of how much of g? All of it. Every term in g has to be changed. So I'm going to rewrite this. That's x minus 5 minus x squared plus 1. Everybody gets the minus x squared part, but they forget to make the negative 1 into plus 1 because it's minus a negative. And now I'm going to combine like terms just like I did on the last one. I got negative x squared plus x. This time I'll get minus 4. Anybody got any questions about what's going on there? Just combining like terms. Part C wants me to do f times g of x. Are you noticing that there's no symbol in between f and g for me to be multiplying them together? So that means I'm going to take x minus 5 times x squared minus 1. Now, if I multiply two binomials or two functions, what do I have to do? The distributive property. Okay, so I'm going to take the first term and multiply it by both of the terms in the second set of parentheses. So I get x to the third minus x. And then I'm going to take the second term and multiply it by everything in the second set of parentheses. So I get minus 5x squared plus 5. No like terms. If you want to, you can put it in order so that it's in the descending order that we like to have things in. That's done. Again, what's the domain on everything we've done so far? I hadn't talked about it, but what is the domain on every single one of those? All real numbers, because there's no fraction and there's no square root. Those are the only things we have so far that causes us problems, or a fourth root or a sixth root, an even root, right? So if it asks for the domain on those, and the second part of this is to find the domain on everything. Then the domain of this one is from a negative infinity to a positive infinity, or you can write all real numbers or whatever you want to do. X is an element of the reals. D. f divided by g of x. So we know the domain's not going to be all real numbers, right? So it's x minus 5 divided by x squared minus 1. You're done with that. You can't combine these. Can't reduce it any, right? I can factor the bottom and make it x plus 1, x minus 1, but it doesn't reduce with anything in the top, so it doesn't do me any good. Do not, absolutely do not, cross out your x's if they're attached to a number with a plus or minus sign behind them. They cannot reduce this. But the part of the work that we have to do on these problems is that we actually do have to find the domain. So what do we have to do to find the domain? Take the bottom and set it equal to 0. So the domain is everything except 1. If you put it in that type of notation, or you can say from a negative infinity to negative 1, negative 1 to 1, and 1 to a positive infinity. Any questions? Checkpoint 3 covers the same material, but it's just got a little bit more complicated functions. On checkpoint 3, it says we're going to let f of x be equal to the square root of x minus 3, and g of x is going to be equal to the square root of x plus 1. And they want us to find f plus g of x. So that's the square root of x minus 3 plus the square root of x plus 1. Right? Any like terms here that I can combine? Say no. And remember, for me to be able to combine square roots, then the stuff under the square root has to look exactly the same. Right? So, part B on here, and you're done, so you're done with that, listing them just like that. Part B wants the domain. Okay? So remember how to do the domain on square roots? Take the stuff underneath and say it's got to be greater than or equal to 0. So out of the first one, I have that x minus 3 has to be greater than or equal to 0. But it is true that x plus 1 has to be greater than or equal to 0 at the same time. I can't have it be either one or the other. So I guess really this makes this an or statement, because I can't let it be either one. Doesn't have to be an intersection. So solving this for x, I get x is greater than or equal to 3, and x is greater than or equal to negative 1. So I'm going to do this one in red. Okay, this says that I can have the stuff that's greater than 3. Right? Nah, I skipped to you. This is an and statement. I had it right to start with. Hush up, boy. And it also says that x has to be greater than negative 1. Now, what's my solution here? What's my domain? I know if I pick a number down here less than negative 1, it messes both of them up, and I know I can't have that, right? But what if I pick a number like 0? Would 0 work? Because if I put 0 into this one, it's still going to be negative, right? And they both have to be positive. So that's why the and statement means an intersection, George. So I have to have the place where I've got both lines drawn. I can't have just be one or the other. So my final solution here for my domain is that x has to be greater than or equal to 3. Can't be anything smaller than that because then it's going to make either one or both of the others, of the function. One or both of the two terms of the function will have a negative argument underneath the radical. Everybody understand? You have to have the intersection for this to work when you've got more than one thing that's a limiting agent. Nope. Going with this? The next objective is objective 3, and we're going to actually talk about these composite functions. This is a new operation. We've never had this operation before with numbers, but we can do composite functions. Composite functions are notated with a circle between them. F compose G. That's why I said if you see F and G side by side, that means times. F compose G does not mean times. They use an open circle. That means F of G of X. So in other words, what I'm doing is I'm going to take a G of X function. I'm going to take a whole expression and I'm going to replace X with that expression. Y'all have been doing this. When you did that F of X plus H, remember you took that expression X plus H and replaced X with it? So you've been doing this idea already. That's called a composition. So, this is the definition for composition. It means that we're going to take the G of X function and replace X and F with it. And we need to talk about the domain. This is in a blue box on page 226 if you want to look at it with me. The domain of this composite function is all of the x's such that we have to have two conditions met. That x is in the domain of G. And that G of X, so in other words, the Y value that you get back from plugging in that X into G has to be in the domain of F. So I want you to think about this for a minute. When you evaluate these functions, this is what you do. You put the X that it asked you for into the G function. Then you take the answer to that problem, the Y value, and plug it into the Y. That's what that function is saying to you. That's what that notation means. Okay, so that means that I've got to check the domain of G and make sure that the result that I get back for G of X is in the domain of F. So let's look at checkpoint 4 and talk about actually forming these composite functions and what that looks like. So if they tell me that f of x is equal to 5x plus 6, and that g of x is equal to 2x squared plus 2x, no, minus x minus 1. So part A says I'm going to do f compose g of x. Now remember what that means. I'm going to take the f of x function. I want everybody watching. Let me give you a second to catch up with your writing. We good? All right, I'm going to take the f function. Everybody see the f function right here? I'm going to write it down, except where the x is, I'm just going to put a set of parentheses, because what this says is I'm going to take the g function and I'm going to put it into the f function. So where the x is in the f function, leave a hole. Now what you're going to do is you're going to stuff this g of x function in that hole. So I'm going to put the 2x squared minus x minus 1 in there. We're not multiplying them together. We are stuffing one inside the other. Okay? Now, when I simplify this, I am going to multiply, but I'm just going to distribute that 5. So I get 10x squared minus 5x minus 5 plus that 6. That wasn't multiplied by an x, so I don't do anything to it. I just write it down. Everybody see what I did? And then when I combine like terms, that's 10x squared minus 5x plus 1. You good? Now, you remember that thing called commutativity, which says that I can do 2 times 4 and 4 times 2 and get the same answer? So it doesn't matter which one comes first and which one comes second. We do have commutativity of multiplication. We have it of addition. But we do not have it of subtraction, right? Because 4 minus 2 is a different number than 2 minus 4. So I remember that commutativity idea applies for some operations and it doesn't for others. Well, it does not apply for compositions. Everybody hear what I just said? G compose F of X most of the time will not be the same number or the same answer. Because why? Because this says I'm going to take the G function, so I'm going to put the 2 down. I'm going to open a hole where the X was. I'm going to put the square on it. Everybody see what I'm doing? Minus, I got to open a hole for that X, minus 1. So everybody see that I just wrote the G function down, just everywhere there was an X, I left a hole in it. And I notate that with a set of parentheses. Now I'm going to take the F function because I'm going to put the F in the G. And I'm going to replace all of the holes or stuff the 5x plus 6 in all the holes. Now, of course, they want you to simplify this. They don't want you to leave it like this. So on the answer choices that are multiple choice questions, when you do that on the final or on the test, you got to know how to get from here to the final answer. So what would you do here first? 5x plus 6 times 5x plus 6 is exactly right. So you'd get 25x squared plus 60x plus 36. Right? Formula is I square the first term, first times the second times 2 because there are 2 of them, and the last one squared. If I'm subtracting off of parentheses, I need to do minus 5x and minus 6, minus the 1. I'm go ahead and distribute that minus sign through there, get rid of that parentheses. So I have to multiply through by the 2 now because I had to wait to do that until after I squared. So I've got 50x squared plus 120x plus 72 minus 5x minus 6 minus 1. And that would, when I combine like terms, that would give me 115x and minus 65. Is that what y'all got? No? Yes? Thank you. And then part C on that checkpoint says they want us to find G compose F of 1. Now, you have 2 choices on how to work this. We have the G compose F function here. So we can just take the 1 and plug it into that function. Everybody understand what I just said? The other thing that you can do is if you haven't gone to the trouble of doing the algebra yet, and they just ask you to do something like this, then you can also do G of F of 1. And this is like I was talking about on the domain. The x value is 1, right? I'm going to take that 1 and put it where? Into the F function. Okay, so I'm going to do G of the F function here was 5x plus 6. So So I've got 5 times 1 plus 6. So I'm going to take the 1. The 1 only goes into the f function. Doesn't go into the g function. What's going to go in the g function? The y value that goes with that x value. Everybody understand? So 5 plus 6 gives me 11, so I'm going to actually do g of 11. So then I go to the g function, which was 2x squared minus x minus 1, yeah. And then if I want to do g of 11, then I do 2 times 11 squared minus 11 minus 1. So it's 121 times 2, 242, minus 11 minus 1, minus 12, so that's 220? No, 230. Yes? Or like I say, you could have put the 1 into the composite function that you did, and that would have given you 50 plus 115 plus 65, which would have given you the same 230. Okay? The only reason I showed you this is because you're going to need to know how to do this in a minute. For the checkpoint? Oh, not g of f? And it's negative 1. Okay, I could actually do the problem that's in the book. That would be so good. Oh, I see what I did. I did the example 4 problem. And did y'all see where I did? I got on the other page. Yeah. So this is just example 4, part C. Here's the checkpoint for part C. All right. Well, it's not the same functions as example 4. So it's my functions. It's just an extra example. Just put a star behind it. Say extra. Over and be above. We don't write that. All right. Yeah. So we're going to do the shortcut. F composed G is 10x squared minus 10x plus 1. I don't know what I said, but did I write it right? 10x squared minus 5x plus 1. And then, since that's the F composed G function, then I can just take that negative 1 and put it in for x for it. So I've got 10 plus 5 plus 1, which is 16. All right.
Has anybody ever watched one of these videos on here and heard me talking about that?
Checkpoint 5 is for determining the domain for composite functions. So this is, we got So first of all, they want me to find F composed G of X, and then on part B, they want me to find the domain. Because remember, this one's kind of interesting when it's a composite function. And this one's even more interesting because they're fractions, right? With variables in the denominator, so I am going to have some things excluded. So first of all, F composed G is I'm going to take the F function. Everybody see I just rewrote the F function? And where the x was, I'm going to put in the g function. Now that is a complex fraction. And there are no books that leave answers in complex fraction form. So to be able to simplify this and put it so that it's just a fraction, I've got to get a common denominator on the bottom. So what is that common denominator going to have to be? It has to be x. And so for the 2, which is 2 over 1, I'm going to have to put 2x over x for it to be able to be added. So this becomes 4 over 1 plus 2x over x. Okay, which it's better now because it's just, instead of having 3 terms, I've now got 2. Even though one of them's kind of an ugly looking term. And now the way complex fractions work is once you get the denominator, so it's just one fraction, you just bring it to the top and multiply. So this becomes 4 over 1 times x over 1 plus 2x. So you just get 4x over 1 plus 2x. Okay? That's f composed g of x in the form that it's going to be in the back of the book when you check your answers or on a multiple choice test. Okay? Shira, I'm noticing that you're checking up on me. Now, let's talk about this domain. Remember, I have 2 conditions for my domain. First of all, the x value has to be something that's defined for the g function, right? So that's, I'm putting the x's in g first. Take the x's and put them in g. So what x's can I not use in the g function? It says 1 over x. This is not a hard thing. What makes the x 0? 0, right? So I cannot use 0. So in my domain, I already know that part of my domain is going to have that I can't have 0 in there. Okay? Now, I also need to know when is g of x going to be the number that gives me a 0 in the denominator of f of x. Okay, everybody hear what I just said? I need to know when g of x is going to give me a number that gives me a 0 for f of x. So x plus 2 can't be 0, right? Y'all following what I'm doing here? I just took the other denominator. Yes? And so x is negative 2 there. But it's not that x can be negative 2, it's that g of x can't be negative 2 on that one. Everybody hear what I just did? So g of x is 1 over x, so it's 1 over x that cannot be equal to negative 2. Everybody understand? On the first one, on the g of x, you can just set the denominator equal to 0. On the second one, you set the denominator equal to 0, but then instead of leaving it x, you've got to put that whole function that g of x is equal to and then solve it again. There's going to be 2 steps to this part. So x cannot be equal to a negative 1/2, right? Because I can reciprocate both sides. Do y'all remember that? Okay? So the 2 things that the domain cannot contain is 0 and a negative 1/2. Go ahead. Go right ahead. We did not get it wrong. I did the wrong problem. No. What? Some of you have before. Okay, I'm going to remember that when I'm grading y'all's papers next, and I give somebody partial credit for at least having done the wrong problem that they put down on the quiz correctly.
Okay, I've done that in the past.
Exactly.
I'm not holding it against you. I'm not holding it against you this time.
He's just saying he's checking, and that's cool. Nice to have somebody check it.
You can just tell us that you messed up on the quiz, but we're not, That is wrong.
Well, didn't Anthony make me do the right one, though? So there's some penalty involved to not doing the right problem.
It's just the fact that I'm wrong.
Okay. So anyway,
We're not perfect.
any questions about how to do this domain thing? You take whatever's on the inside, you just figure out what gives you something bad there. Set it, if it's a fraction, set the denominator equal to 0. If it's a square root, then you set it greater than or equal to 0. But then you got to do the same thing if there's a problem with the f of x function. Now, if f of x had been x squared plus 3 minus 5x to the third, no, I wouldn't have had to do anything, because is there anything that I'm going to put into a polynomial function that gives me a bad number back for a domain? No. So you don't always have to worry about both. The only reason I had to worry about both on this one is why? They both had the x in the denominator. Okay? Does everybody hear what I just said? The only time you have to worry about doing these double exclusions like this is when f of x and g of x both have things that have to be excluded. That doesn't happen very often. Okay? Any questions? All right. So what are the only times that you have to worry about excluding something? Well, when there's a variable in the denominator of a fraction, or if there's what? An even root, and the variable's underneath the even root. Okay? All right, there's one last thing. The objective 5 is on decomposing functions. Has a decomposition. Decomposing functions just means I'm working backwards. I'm thinking about what composition could I have had that would give me this result. So if you have something, checkpoint 6, tells me that I have that h of x is equal to the square root of x squared plus 5. Now let me tell you now that there are lots of right answers here. Okay? I'm going to give you the simple way to do this. If you'll notice, I've got the square root of something, right? So if I had let one function be the square root of x, and what I replaced x with was x squared plus 5, so if I have f of x is the square root of x, and g of x is x squared plus 5, then f composed g of x would be equal to h of x. Do you get that? Because I took the g of x, and I stuck it in for the x on the f of x, and that's what gave me h of x. Does it take the jump kind of underneath? Make that all your g of x, and let your f of x be. Just replace all that stuff that you just pulled out with just the x. There are lots of right answers here, so there's lots of ways to do stuff. If you had that h of x was equal to x squared plus 4 to the third power. Here's my example. Okay? Then this is how I think about it. I'm going to let g of x be the stuff inside the parentheses. And then f of x is going to be where I pulled all that stuff out. It's going to be turned into just an x, and then I'm going to write the rest of the problem down. Okay? Just the easy way to do it. There's more than one way, and some people are going to come up with some different things, and that's cool. There's lots of right answers here. But that's just the easy way to do it, just to pull everything kind of out. If you can find like this place here. Just remember that if you've got another x anywhere else, then you're going to be replacing it with that same thing too. So you kind of got to be careful if that appears in more than one place. Okay? All right, that's all that's in this section.